loud.
Recording in progress.
Perfect. Okay, great. We are recording. All right, so we're going to talk about logs again. So this unit is going deeper with logs. So what we're going to do is we're going to start solving equations that have logs. We're going to start solving exponential equations that look kind of crazy. We have to use logs. We're going to be combining several log expressions to condense them or simplify them so we can easily do these things. This will give you a lot more flexibility with stuff you do in pre-calculus and calculus in the next couple of years. So, and this does get reinforced anyway in pre-calculus, because I assume everyone in here is going to do some level of pre-calculus. But anyway, before we do that, let's revisit some things about exponents, right? And remember, logs are the inverse of exponential functions, as you see in the first sentence up top. And the properties are similar to ones you already know. So let's talk about the properties you already know. So let's take a look at 6106. And you see two powers, right? So something that you guys should already know. So you have x to the a and x to the b. So these are two powers with the same base. Likewise over here as well. And remember, x to the a, this whole thing, in case you guys forgot. Whoa, someone's really upset. The whole thing's a power. The whole thing's called power. What does the x call specifically, though? What do we call the x, then the bottom of the power? What do we call that? Base, good. Like a basement, or the base for if you're building a house of cards, you have a base for that or whatever. Yeah, you build a base, right? And then what is the a called? What is that? What do we call that term? The exponent, because it's kind of extra, it's kind of up there, far away, right? That's how I kind of help myself remember it. But don't call x the power or a the power. The whole thing's called the power, right? X to the a is called the power. And then base is the bottom part of the power, and a is the top part of the power. So here we have x to the a times x to the b. Those are two powers of the same base. How would you combine those exponents? You say x what power? A plus b. Yeah, you always add them. How about the other one? What would you say for that one? So when you combine as one, it becomes b minus a. Very good. Right. So basically you multiply. So when you multiply two powers, you add the exponents. When you divide two powers, you subtract the exponents. This is all stuff you've done in the past, right? Now we're going to do something very similar with logs. Very, very similar. And it's kind of the opposite in a way. So when you see a plus here, what this will mean is you're going to multiply the inputs. So you have a 5 and a 6. What's 5 times 6? It's 30, right? And let's prove it. If I prove it to you guys, I'm going to go to a calculator. Be right here. Math department, Wabbit Emu, browse, that guy, finish. There we go. Yeah, so just to prove to you guys, let me go and clear my screen for a moment. If I do log 5 plus log 6, you'll get a nasty decimal, so be it. If I do log 30, you get the same thing. So it's kind of similar to what we've been talking about with exponents, right? If you have two logs with a plus in between, you can actually multiply the two numbers inside the logs or the inputs. You can multiply the inputs. This is totally something that's true if you're adding two logs. So let me go ahead and undo my writings. So for the next one, what do you want to say for the next one? Now that you know we multiply these. 10. How about next one? Next one. There we go. And it kind of makes sense. Like, let's look at 4. That one's kind of interesting, right? Let me rewrite it. You don't have to rewrite it. I'm just going to do it just because I want to. Log 10. That's 1. right? Because 10 to the 1 power. Remember, when you don't see a base, what do we see the base of? You guys remember? What do we see the base of? You don't see one? 10. So it's common log, right? So 10 to the 1 power equals 10. So that's 1. Log of 100. So 10 to what power gets me 100? 2, right? And then 10 to what power gets me 1,000? 10 times 10 times 10, 3. And that makes sense because 1 plus 2 is obviously 3. So we know this is making sense now that, yeah, okay, in fact, 2 logs being added, multiply the inputs. Multiply the inputs. And again, you could plug in a calculator, but I kind of am doing it for you right now. So here, same thing. That'll be 99. And that'll be AB. So the bottom line is this. When you have log base A of X plus log base A of Y, it's always going to equal log base A of X times Y. This is called the product property. Is good.
What's the base of?
So the one I just wrote right now in P is base A. The ones up here all have base 10. The bottom line is all the bases are all the same. You can combine the ones. So that's a takeaway. Once again. Well, no. We did base 10 in the examples, but I'm just telling you generally. Oh yes, yeah, yes, there, yes. Yeah, go ahead, Monty. Hmm? Oh no. I worked at each log first, and then I just to prove to you that makes sense. Now, once you have like a straight up number, of course you add them. But what the point is, when you have logs, if you want to combine them, you have to multiply. Yeah. So the takeaway here is that when adding 2 log expressions with the same base, you can combine those log expressions as a single log by multiplying the inputs. That's the takeaway there. When adding 2 log expressions the same base, you can combine those log expressions as a single log by multiplying the inputs. That's exactly what we just did. So that's verbally, that's mathematically, which kind of looks like Greek sometimes, but it's called the product property for a reason, because you're multiplying. Products is multiplying, right? There you go. So now, what do you think is going to happen for the next one for part C? Yep, there you go, just division. So you're just going to divide these suckers, right? So you're going to do 20 over 5. Well, actually, I'll just tell you. We know it's 4, obviously. What's 30 divided by 3? 10. 5 halves. That's a 10. 17 over 9. That's kind of funny. Whatever that is.
That's something that we
You're probably right. Just want to be sure. Actually, yeah, because it has to be divisible by. Nah, just a fraction's fine. Yeah, because 17 has to have a factor of 5, which it does not, so it's not doesn't come out clean. And generally speaking, just B over A. So yeah, and just to prove to you, let's go to the calculator. If I did log 20 minus log 5, and did log 4, well, voila, there you go. They're the same thing. So the next one is called, yeah, go ahead, Jack.
Let's say log 3, 5 plus log 6. The base is 3 now. How does that alter it?
Oh, the bases are different?
No, basically the same.
Oh, yeah, it's just the same thing. Same thing. Yeah, it doesn't matter. As long as the bases are all the same. As long as the bases are all the same. So what I'm going to do is let me do a quick edit here. You may want to write this again elsewhere, but I'm just going to do it on my screen because I don't have enough space. So now if there's a minus in between the 2 logs, then you divide. And that's called the quotient property of logs. I don't have enough space, so that's why I'm just updating, but you may want to write this again. Log base A X minus log base A Y. And if I update this guy here, when subtracting, let me switch this to green. Oh, okay. Oh, whatever. I was going to try to see if I can do different colors within the same text, but I can't. When subtracting two log expressions the same base, you combine those logs as a single log by dividing the inputs. And that's the takeaway there. So again, it's quite analogous to properties of exponents, right? In fact, actually, we kind of see it's pretty darn similar, right? Like if you do x to the a power of x to the b power, it's that, right? It's pretty similar, right?
Like here you got subtraction and division, subtraction, division. Just don't mix it up. Be careful with what you do. Like don't get these. Like don't also think you can divide these and then it's the shortcut. The bottom line is if you divide between two logs, you can make it a single log as division.
So you don't want to get these confused, because it's easy to confuse the stuff. Questions? Yeah, Hunter, go ahead. Product property is called. Yeah. It's called quotient property, because quotient is when you divide. All right, let me go and clear the sucker. Let's move on. Before you turn to the next page, check with people on your team. We already talked about it. Let's move on. Okay, so write down log properties you discovered. Well, I just told you what they are. It's supposed to be a group activity. Oh well, I just told you. So again, generally speaking, here it is: log base a x plus log base a y equals log base a xy. Log base a x minus log base. I'm just repeating what I put on the previous page. So if you want to write again, go ahead. Probably doesn't hurt to write again. So there you go. So, yeah, we can kind of work through this puzzle here. Let me zoom out a tad. Just kind of a lay of the land here. Okay. All right. So let me kind of get us kickstart with maybe the first row. Then I'll have you guys kind of work out this other stuff. So what's the base for the first row here? Base 3, right? So if you have log base 360, then it's log base 3 of what? 10. Perfect, yes. Or you can write like this, log base 3 of what? If you have a 3, what are you going to multiply 3 to get 60? 20. There you go. Those are all equivalent. Or I can write as a quotient. 120 divided by what gets me 60? 2. Or 240 divided by what gets me 60? 4. So all is true. All that works for us. So the second row is kind of open-ended. You kind of have some freedom here. Log base 7 plus log base 7. What two numbers can multiply 36? Just give me two numbers. 6 and 6, sure. Or what else? 3 and what? 12, good, yeah, that works. There's plenty of options, right? These are the ones we went with. Give me two numbers that divide to 36. Yep, 72 and 2. If you want to be lazy about it, you could say this. What's 36 divided by 1? Yeah. And by the way, log of any base
Put 1 is always 0. Because 7 to what power gets me 1? 7 to the, yeah, always think like this, right? This raised to 0 gets me this. Remember, what does this really mean? It's 1 equals 7 to the 0 power. Right? That's all that it means. So, yeah. So that makes sense. Because of course, like I said, there's 6 people. So,
okay, go ahead and try the next 3 lines and check with your teammates. I'm gonna or table group members, whatever you want to call each other. I'm gonna freeze the screen. I'm gonna work it out, and then I'll unfreeze, show what I got. And the answers are kind of open ended. There's not really a for sure, right? There's several answers that could work. So let's go and freeze. Let me do this right now. Almost done here. Oh, come on, man. Here we go. All right. I think I got some stuff here to share with you guys. Okay, again, yours don't have to be exactly like mine, and my handwriting stinks. So if you have a hard time reading it,
please ask. But it's pretty obvious that this is 18, right? 9 times 2 is 18, right? Think about that. That, you know, you can't misinterpret that. It has to be 18. Likewise, this has to be 50, this has to be 40. And then if you want to write 18 again, you can do like 3 and 6. Or as a division, 36, 2, and 18 and 1. As a multiplication for 50, you do 5 and 10, or 2 and 25, or as another division, you do 102. That works. As that's 40, because 160 divided by 4 is 40. As multiplication, you do like 4 and 10, or 2 and 20, or you could have done 5 and 8, or 1 and 40. There's a lot of different options could have done. As a division, again, you don't have to do 80 and 2. I chose 80 and 2. It's infinite possibilities. Actually, it is infinite possibilities, to be honest with you, because I didn't have to do whole numbers in my inputs. If you really want to get creative, you can do fractions. Like, for example, for this one here, I could have 1/2 and 120. Because what's half times 120? 60, right? I can have log base 3 of 1/2 plus log base 3 of 120. There's actually infinite possibilities. I just chose numbers that are easy to work with because we can easily fathom what integers or whole numbers multiply to that number there, right? So, but it's totally open-ended. So questions on this? Hopefully this gives you a better understanding of how the properties work. I think we'll really drive the point home on the bottom of the page and the next page. So here, expresses a single log. Okay. So this is the kind of, so these are actually test problems. 6109. Everything we've done so far is just more just training you guys to understand the properties. This is truly a test question. So you may want to write that down somewhere. Because what we want is we want to condense as a single log. So we're trying to condense each case. We want to condense. Oh, hold on one sec. We can't do some of these parts here. I just realized there's some things I haven't taught you guys yet. Let's actually, let's come back to 6109 in a second or in a few minutes. Let's actually go to page 3 and then we'll come back to 109 because I actually do need to talk to you guys about 6111 before we do 6109. Okay, so again, the product property we talked about, right? This actually proves why this works. So this is actually like a formal, these are actually formal proofs. These are not test questions, just so you know.
So not a test question, just so you know. There's really more a formal proof. This is for me to say that I actually taught you guys well. This is for me, really. Of course for you too, but really just to make sure, okay, I actually showed you guys why this works. So let's say a equals m to the x. Let's say b equals m to the y. So when you replace a and b with m to the x, m to the y, you wind up getting this. Does that make sense what I just did? I just replaced a and b, right?
So A is this and B is this. And we chose, we had this, we said let, it's independent. You get to choose what you want. But why did I choose that? You'll see. You'll see in a second. So replace A with M to that, replace B with M to the Y. Now what happens to these two guys? These are two powers of the same base. Well, how can you make it one log? Ah, good. Think about it. Ah, perfect. Good.
So be log base m of x plus y. Well, here's the thing. What's that gonna, what happens when these are the same? When the base, they can't show up, we know this now, x plus y. And guess what? If you rewrote this, you can say x equals log base am. And if you rewrote this, you say y equals log base. Oh my goodness, I can't believe I did that. Wow. Sorry, guys. Log base m of a. I know, come on, man. I can't believe I did that. The base is m, not a. My apologies. And y equals log base m of b. I should know this because m to the y is b. M to the x is a. My apologies. That's a y. That's terrible handwriting too. I can do better. Well, guess what? X plus y is log base ma. And initially we had this. And that's why this works.
Initially, we started with this, right? Log base M of AB. So I just bring it back from this. Now I work all this out. Log base M of M to X and M to the Y, by the exponents. Cancel out the log with the base here. Drop back, and figure out the X and Y word over here. And bring it back into this. And this is why it works. This is the formal proof of why the product properly works.
I do this actually with my pre-calculus BC honors class, which is obviously 3 or 4 levels ahead of this class. So it's good that I'm doing this with you guys because you guys do need to see this. It's important you guys see this. Again, it's not a test question, but this explains why the product property logs work. Yes, it's analogous to exponents, but this really shows you why it works. Let's try this again for the quotient property. Again, it's not a test question, but just to show you why it works. So again, same thing. I'm going to replace a with m to the x, replace b with m to the y. And how do I combine those exponents, guys? M to what power? And the log and the m cancels, so you get x minus y. Again, x equals log base m of a. And y equals log base m of b. And then x minus y, log base m of a minus log base m of b. Okay, there we go. So it's very similar to what we just did. Okay, I don't want to move the screen. Okay. The last property, this is why I couldn't do 619, you guys, because I just realized, oh, I haven't talked about the power property. There's one more property that's left. If you think about it, a cubed. A cubed is 8 multiplied how many times? So let's multiply it 3 times. And now we know about this product property, right? How can I break this up? If I'm multiplying a bunch of things, how do I break it up, guys? Yeah, log base MA. Log base MA plus log base of A. How many logs is that, guys? So you do 3 times. So generally what we're noticing is that that 3 moved to the front. So generalization is this. M. So you're allowed.
Kind of a fun play on words. Roll this log, like log one, like securely. That's what I did again. Log one, securely. Yeah. Anyway, kind of playing words. This and I this is like 18 years waiting to get something out in the Well, then I could roll back one, right? I could roll back.
So yeah, those are the properties. So 3 properties there. And we're going to be using this off. This is a great way to set the tone for the week because we're going to talk about this over the next couple of days for sure, using these properties. So now I can do 609. This is a test question, and then I'm done talking. You guys can do homework or just hang out because I know first day back is always a little rough. So let me do part B first. There's a plus. So how would I combine those letters? What would that be? Multiply them. There you go. That's it. Oh my goodness. You caught me. I made a mistake. Yes. Can't be simplified. Good job, Hunter. You're on it because bases are different. That's good. I'm glad I made a mistake so you guys can see that. So you don't do it. Okay. So you guys don't make that mistake. Okay. Now I feel better. Okay. I knew that there was a catch there. I didn't quite see that. Okay. Let's go back to A now. Let's focus on these first 2. How would I combine those first 2? Totally multiply it. Ah, goodness. And then how do I combine 8 and 5 now? There you go. You're at 1.6 or 8/5. I don't care. Same thing. All right. So we got A and B done. Okay. I'll do C up here because I don't have much space. I'll do D here and I'll do E and F below. Okay. For C, there's an X here. Where's that X go? It rolls back. You got to roll it back. It's like the rolling back prices. What ad is that? Rolling back prices. I don't know what that is saying. Log K plus log M to the X power. And then you can combine those by multiplication, right? So log parentheses K times M to the X power. 100% correct. Yes, that's what we do. Okay, go and try D on your own. Should take you just a few seconds, hopefully, maybe 10, 15 seconds. Remember that 1/2 and the 2 roll back. Roll back the 1/2 and the 2. You're rolling back. You should have log base 5 of X to the 1/2 power. Hold on a sec. Log base 5 of X plus 1 squared. And then you can multiply them. It does not, because that would be participating in the order of operations. You don't want to do that. You do not want that to be bad.
Yeah, it's kind of weird, but it's log base X 1/2 times X plus 1 squared. Right.
I'll have you guys try. By the way, for F, we just can't do it. Actually, you could technically. Let me tell you what F is. I'll have you try E on your own. Technically, you could. You could write like this. Can't do 3s, I swear. Do you guys see what I just did with the 23?
I made it a base, because that's base 10 also, right?
log 6 is base 10. Let me put a base 10 there just so it stands out. So yeah,
You have two logs of base 10. And that these cancel out, so these got 23. Now, how would I combine these two?
you multiply them exactly. But you do 6 times 10 to the 23rd. You can't multiply 6 and 10 because that displays order of operations. Yeah. Okay, go and try E now. I'll give you guys a moment to do. I'll freeze my screen. And then we're done. And you kind of want to follow the order of operations in some ways. Oh, geez, can you guys? Oh, I'm sorry. Yeah, move the 3 back actually to the back, but make it R cubed. Here's what I got, guys.
So what I did was I moved the 3 back, make R cubed, and then multiplied to the pi to make it pi R cubed. And then these I divided because you have minus, so I did log 4/3. So log 4/3, log of pi R cubed, then there's another plus, and I can multiply those together, that's 4/3 pi R cubed.
Can you get that? That's what we got. Davis, go ahead.
How do you get rid of the 1/2 too?
Oh, for part D, I moved them back. I rolled them back.
So we got from x to the half and x plus 1 squared. And then I multiply those two expressions together over here. That's that. And here, yeah, obviously I roll the 3 back and then multiply and divide it.
Let me see if this is as a screenshot because it's kind of good. Have this available for you guys. So, but yeah, this is like a test question. 619 for sure. Okay. And then the homework, there's a separate packet for that, which hold on. Did I give you guys? Oh, it's already connected. Yeah, hold on. Let me make sure. Wait.
Yes, wait, yes, that's correct. Yes, that is homework. Yeah, homework is connected. Yes, it's
all part 1 packet. Okay. Got a little nervous there. Yeah, let me go ahead and clear my screen. So there's some review of old stuff, it looks like. That's important. Here we go. And I'll try to create the answer when I get a chance. Yeah, graphing exponential functions. If you need to use Desmos, it's totally fine. Likewise, a 2. If you need to use Desmos, it's totally fine. Or a graphic calculator. But 3 is what I care the most about because that's what we did today. 129 kind of is good because we kind of started talking about this today. And 133, just solving. And if you want to do the extra problems, go ahead, give them a try if you feel so ambitious. Yeah, and we have what, another 22 minutes. So you guys could probably knock this out. Actually, let me work on the answer key right now. I could actually do this very quickly and then scan it and share it with you guys. So yeah, let me stop the recording.